we have visited every planet in our solar system. We either flew by them or we've landed on them. And so that's not actually 8 planets. And we've also landed on one dwarf planet, which we have called Pluto. And it's absolutely amazing, how many, we've actually visited a total of 64 celestial bodies in our solar system. And we've landed on 9 of them. And we're not counting the Earth, because I don't think anyone's ever landed on us. But just to take an accounting of where we've been and where we've landed, we have actually a listing of all the places that we visited. So taking a look, you can see this is actually in size order. And we have not yet landed on the sun. There is a movement by the Flat Earth Society to land there at night when it's dark, but I'm not quite sure where they are on that one. Anyway, but we have visited everything on that list, and we have landed on the ones that have stars. Now you can see that Jupiter and Saturn have slightly different stars than the rest of them. That's because we've actually sent probes into the atmosphere of Jupiter and Saturn, but they don't really have a surface that you can land on. They actually burned up in the very caustic atmosphere of Jupiter and Saturn. But you can see that we've landed on Mars, we've landed on Titan, and others as well. And as we go into the next list, you can see that there is a part, starting from around Miranda and Mimas, the moons actually are no longer round. That's because of the gravity of those particular objects are not enough to squeeze those moons into what they call static equilibrium, or they force them into a round shape. Now, we haven't landed on anything on that list, but the next list is quite something. These are mostly asteroids, although there are a number of comets in on there. And you can see that there doesn't seem to be a whole lot of difference between comets and asteroids. We've actually landed, so to speak, on a comet, and we found it's pretty loose. It's kind of like a gravel driveway, only it's kind of held together by its gravity. So we have landed on these. And you can see the one on the end, Bennu, has a flashing star. That's because we haven't quite landed on that one yet. We're set to land on that one actually around August 20th. So stay tuned. We're going to be landing on that one as well. So it's really amazing that we've landed on these things. I don't think people realize the science that goes into that. And we're going to talk about that. We're actually going to kind of move away from the obvious ones. By the way, there's another one here. As you can see, it's in the second row. It's called Wild 2. Now, Wild 2 is a comet, and we haven't landed on it, but we did have a spacecraft that was right next to it and kind of lapped up some of the debris that was coming off of it. So I'm not quite sure we'd call that a landing or some kind of a lap up, but there it is. Anyway, the first object, the first place that we've landed on, obviously, was the moon. We had all sorts of probes going to the moon, crashing on the moon. The first probe that landed on the moon was a Soviet probe, uh, and that was in 1966. And that was the first, shall we say, intentional soft landing. It was followed in June of the same year by Surveyor 1. And you can see the film of the Ranger falling toward the surface of the moon and taking pictures as it went down. Anyway, but our soft landings were quite spectacular. And one of the first things that the astronomers noted was the fact that the space probe did not disappear under a big mound of dust. There was actually a solid surface to the moon that was maybe about 2 or 3 inches under a layer of dust that had the same consistency as talcum powder. So then after we've sent all these probes to the moon, we decided to go there ourselves. And we have all sorts of pictures for that. Now, there is one thing that all the astronauts have in common after they've been to the moon. Every astronaut that has left the safe, our safe Earth beyond our radiation belts, they have all suffered forms of heart disease. Several of them have died from it. The ones that are alive right now are being kept under some very heavy treatments, but it has been determined that the radiation, the interstellar radiation that is able to reach the astronauts, even when they leave the safety of our Earth and the radiation belts around the Earth, the Van Allen belts, will have some type of cellular damage to the heart when they come back. That all develops after they come back. So this is one big thing we have to consider when we go to Mars. It's entirely possible that when the astronauts go to Mars, they will be subject to this radiation that may actually kill them on the way out. Okay, so let's keep on going here. The next planet that we went to was Venus, and the Soviets actually have Venus. They landed on Venus, although none of their, well, I shouldn't say none of their early Venusian satellites or landers lasted any more than 20 minutes. The tremendous atmosphere of Venus just simply destroyed them. Now, they claim that their Venera 4 actually landed on the surface of Venus because they were able to get pressure readings. That was in October of 1967. What's interesting is the fact that the next day, our Mariner 4 actually flew past Venus and took some readings of that, and they found the atmosphere to be more than 5 times the amount that the Venera 4 actually measured. So the Soviets retracted their claim, saying in essence that their spacecraft probably was crushed by the tremendous pressure of Venus on the way down. So the atmosphere of Venus is absolutely, it destroys anything, really. The clouds are sulfur, or actually sulfuric acids. The atmosphere is so thick that if you just simply walked through it, you would be like walking through hot tar. So it's not really a very nice vacation spot. Now, none of the probes actually lasted more than an hour on Venus. And we sent a whole bunch of cameras up there. There's our Mariner 4. The Soviets, when they sent their cameras back, they showed a rocky surface and a fairly hazy atmosphere. Temperatures on Venus were in the 900-degree Fahrenheit range. So in reality, Venus is the hottest planet in our solar system, even though it's number 2 as far as position is concerned. But you can see it's kind of a dull place to visit. Now, one of the things that the Soviets did send to Venus was an awful lot of these, shall we say, souvenirs. This is actually a sphere of banners, and when it was actually on the surface, it exploded, sending all these banners all over the surface. And what's interesting is the fact that they weren't claiming Venus to be their own. What they were doing was just basically marking their territory, and not necessarily their territory. They were just showing that they were first on there. Kind of like setting up a flag. And they have all sorts of little banners that they sent to the other planets as well. I mean, the moon, Venus, Mars. So they found Venus. You know, here's our Venus probe. It was actually 4 probes that were sent to the surface while we had a orbiter basically relaying the information. Now, only 1 probe made it to the surface. And again, it measured the surface temperature at more than 900 degrees. And the pressure, the air pressure, was actually, it was 90 bar. How much is 90 bar? That would be 90 times the thickness of our atmosphere. So like I said, it would be like walking through just a pit of hot tar. Anyway, but like I say, one of these made it to the surface. And what's really kind of frustrating on this is the fact that there were no cameras on any of them. They just didn't want to take the bandwidth to send back pictures. The next planet we landed on was Mars, but we visited Mars 2 weeks ago, so we're not going to talk much about Mars. Next planet, I think one of them has a gun. The next planet that we're visiting is Jupiter, and Jupiter had a number of probes sent out to it. Had the 2 Pioneers, had the 2 Voyagers. Next one was the Galileo, and the Galileo not only took pictures of Jupiter, it also took pictures of the 4 Galilean moons and a whole bunch of little moons. And as you can see, it actually took off from the Earth in October of 1989. And it was the 5th probe that was sent through the asteroid belt. And there was some real concern about that. They thought for sure that this satellite, this probe, was going to get bombarded by hundreds of little asteroids. Nope, it went right through. Actually, we've had a total of about 10 probes go through the asteroid belt, and not one of them was hit. So it certainly isn't as populated as we thought. Anyway, as you can see, it was launched from Earth. It passed by Venus. It passed by Mars. It stopped by, actually it didn't stop anywhere. It actually flew by the asteroid Ida, and it finally reached Jupiter in actually December of 1995. The probe looks amazingly like the Voyager that went out so many years before, and it was kind of based on that because it was a fairly successful design. But it did have one addition to it, and that is that little thing on the bottom that's circled. That is a detachable probe that was sent into the atmosphere of Jupiter. And the probe detected extremely strong winds, very intense turbulence, extremely intense radiation, and all this before it finally gave up several hundred miles into the atmosphere. So it was sent into the atmosphere. I'm not even sure how long that parachute lasted, but it on the way down, again, no pictures. It was just taking readings of the atmosphere. And it found some very interesting things about the atmosphere of Jupiter. For one thing, the atmospheric pressure increased tremendously as it went down, where it finally gave up. The atmosphere was about 20 times that of the Earth, and the temperature was over 260 degrees Fahrenheit. As they thought, most of the gases on Jupiter were hydrogen and helium, although it did have a lot of methane and ammonia and equal amounts of water. Now, obviously, this isn't the type of water that comes out of your tap. It probably had ammonia and methane mixed in with it. Not a real good combination. It had organics, which is carbon-based materials in there. So it had a lot of, so I say, old atmosphere that was part of that. After its mission was over, on September 21st, 2003, the probe was sent into the thicker atmosphere of Jupiter, where it actually burned up. Now, I don't know how long it took before it actually reached whatever surface there might be on there. I'm not sure if it really has a solid surface like we would think of. It might have hydrogen that would be in a metal form. But I don't think there was anyone down on the surface that would have been able to use those parts. So let's keep on going. The next probe that went to Jupiter was Juno. Juno was launched on August 5th, 2011. And as you can see, it's the size of a basketball court. It is the largest solar array that was ever put on a spacecraft. As you can see, it was actually using Earth as a gravity boost in order to get it out to Jupiter. Now, what's kind of sad here is the fact that one of the boosters did not operate when it finally got to Jupiter. So it had a slightly modified orbit. We'll get to that. What the probe did, it took a look at the tremendous magnetic field of the planet. It has the largest magnetic field of any planet in our solar system. And as you can see, Juno kind of dipped in under the radiation belt. At its fastest, it was going almost 140,000 miles per hour when it passed by the planet at that point. As you can see on top, we have the magnetic field, we have the aurora on Jupiter, and it also took very good pictures of the red spot. And you can see it's about the size of the Earth. Now, I have seen the red spot through a telescope, and I can attest to that. It is not red. I have always called it the Great Beige Spot, because that's what it is. That's how it looks. I'm sorry, I read them like I see them. Juno also, took pictures of, it actually compared the red spots going back in time, and you can see very well how much that red spot has decreased over the years. It's been said that the red spot is actually a cyclonic storm on the planet. If it is, then it's been there for a couple of hundred years, which is similar to some of the cyclonic storms that are in Iowa. Probably not quite as destructive. Now, I mentioned before about the weird orbit that Juno was in. And to give a look at the orbit, it actually is a very oblong elliptical orbit. And each time it passes, it takes more pictures. And as you can see, it actually extends into 2021. So it's still going around Jupiter now. At some time in the future, we will let it fall into the atmosphere where it'll burn up. Okay, at this point, we're going to look at the next probe that went out there, and that was Cassini. Cassini was launched on October 15th, 1997, and it took 7 years to get out there. Isn't it amazing that they can build something that'll take 6, 7, and in some cases 12 years just to get out to where it does its job? Why can't they do that with a dishwasher? I mean, and the dishwasher isn't subjected to all the tremendous, terrible things that space has in store for it. I mean, a dishwasher, here on the Earth, should last 20, 30, 40 years. But here you have space probes that are very complicated, and they last 12 years without any problems. Oh, well, I guess I'm mouthing off here. Anyway, Cassini was launched in 1997, and its job was to go to Saturn. And I just love the way they have similes showing what various parts of this particular probe is. Like they have the eyes as cameras, they have a baby as the Huygens probe, a baby. And then they have dancing legs as the orientation thrusters, 1 of 4. They have food, that's the power supply anyway, but I kind of getting away from myself here. But the idea is that you do have a probe that has a lot of different functions. And the first thing that Cassini did when it got there was to actually fly through Enceladus's plume. It's a water plume. It's actually a geyser of water that was being sent up by this moon of Saturn. I mean, it discovered free water on another planet. And from there, we realized that water is probably the most common molecule in the universe. You find it everywhere. If there is any kind of chemical reaction at all, there's water there. So it flew through the water plume and was able to send back that information, much to the surprise of the scientists here on the Earth. Meanwhile, it does have a baby, and it's right there. That is the Huygens probe. It's actually named after an astronomer named Huygens. And what it was taxed to do was to land on the largest moon of Saturn, Titan. Titan's been watched for a whole number of years, and they found that Titan has gas clouds, it has a solid surface, it has rain, but it's not like anything that we're accustomed here on the Earth. So there's the little doodad, and has batteries in it, and it was made to land on the surface of Titan. It took a picture or two, and then it also sent back a whole lot of information about the atmosphere. So here's Cassini taking pictures of the landing area on Titan, and finally the approach and landing took about two and a quarter hours to finally get down there. And let me tell you, they were holding their breath until it finally landed there. So we have the aerial views of Titan right around the Huygens landing site. As you can see, there's about 5 miles up. And then we have 1 mile up looking in all 4 directions. And finally, we get down to about 500 feet. And this was the last picture it took before it finally landed on the planet, on the moon itself. And when it did, this is what it found. Going through the atmosphere, it found that it was nitrogen rich, like us. We're nitrogen rich. It went through kind of a methane haze. It went through a methane rain, and finally landed next to a lake. I'm glad it didn't land in the lake. That would have been about the luck, about all that. But the surface has a lot of lakes, but again, it's not like the lakes we have. The picture on the left is actually tremendously foreshortened. The rock closest to us is about an inch or two wide. As you go out, the sizes are exponentially larger. And the ones in the surf on the horizon are several hundred feet wide. So it's kind of a really foreshortened picture. The actual, here you can see how foreshortened some of these things are. The actual picture of the surface, the color picture in the middle shows you that everything has a haze around it. And that haze is a methane haze to it. On the right, you can see the lake on Titan compared to a lake on the Earth. And you can see that this lake is quite large, has little islands in it, and watching this uh, lake, you can actually see that there are tides on the planet where islands will actually appear and then disappear over time as the tide comes in and goes back out. So it has a water cycle very similar to the Earth, where we have methane rain. The methane will then evaporate into the clouds and then come down as rain one more time. But again, this is methane rain. Now, what's interesting is the fact that there are tidal pools on the planet, and these tidal pools might be similar to the tidal pools on the prehistoric Earth, where various forms of microbial life may have suddenly started to grow. It is possible that some type of extremophiles would be able to exist on the moon Titan. However, they wouldn't be breathing air like we would. They might actually be breathing cyanide, which would not be very healthy for us. But if you happen to be on a planet where you needed cyanide to live, then maybe ammonia isn't your choice for breathing the clouds that surround Titan. Maybe you would need cyanide. So this is actually some type of prebiotic chemistry, which might be a precursor to life on Titan. If you take a look at Titan, at least one of the poles, you'll see that there is a kind of a whirling vortex on that moon. And it's just like every other moon or planet that has weather. In fact, you can compare this to the vortex that you find on the planet Saturn itself, except that the planet Saturn has a vortex that is hexagonal in shape, and they don't know exactly why. This is really unusual. It does have a whirling vortex that's inside this hexagonal cloud cover, but the hexagonal shape is really a mystery. Anyway, as Cassini moved on with its life, it got closer and closer to the surface of Saturn. They finally moved it so that the final orbits would actually take it inside the ring of the planet, where it took us some final pictures of the planet and then ended its journey in 2017 by burning up in the atmosphere. Next, we have deep impact. Now, deep impact was actually a way of looking inside of a comet. I mean, we have to get up there with a shovel and dig a hole and take a look inside. Well, that wasn't very easy for anyone to do. So they decided they were going to send a probe out there, and then they were going to blast this huge piece of copper, weighed 800 pounds, and they were going to send that right into the surface of that comet. And then hopefully they're going to blast some of the insides up, and then about a day later, the spacecraft, the space probe, was going to fly over it, take a whole bunch of pictures, and actually analyze the stuff that was blasted into space. Good plan. They hadn't thought of one thing, though, and we'll get to that. First of all, they had to get out there, and of course, it took uh, only 6 months to get out there. I mean, that's not too bad. Uh, and so they got everything ready, and there's Temple One. By the way, at the time that I was involved with astronomy, when Temple One was being bombarded, I noticed that there was actually a peace treaty that was signed by the inhabitants of Temple One, begging that they not be bombarded. Of course, nobody listened to them. So anyway, the 800-pound copper impactor was blasted off toward this comet, and sent a whole bunch of stuff into space. What they didn't count on was the fact that this plume of debris actually blocked any research that the probe was going to do when it passed over Temple One. It couldn't see a thing. It was, I mean, they did find some minerals on there. They found all sorts of metals and silicates and sulfides, carbon, all sorts of stuff on there, but they couldn't get any pictures. Meanwhile, with the thought that you never throw anything away, there was another probe that happened to be orbiting the Earth at the time. It was the probe that had looked at Wild 2. It was the Stardust probe. And it was just minding its own business, orbiting the Earth. And somebody said, why don't we wake up that probe and send that one past Temple One, and then we could actually see what's going on. So they did. They changed the orbit of Stardust since it was sitting in a parking orbit, and they put it into a new orbit so that it would approach Temple One. It was now called Stardust Next. Good name. Now, Stardust was a probe that was sent out several years before. It was approaching Wild 2, and the idea was that it was going to not only take pictures, but also that little fan on top was going to capture all sorts of dust and dirt from that comet so that it would send it back to Earth. And it did. And then it was done. So now we're using it for something else. So they put it into an orbit so it would pass by Temple One, and this is what it saw. You can almost hear the Doppler shift as it goes by. And it took before and after pictures. So before is on top, after is on the bottom. And you can see that things kind of got covered over from the dust. The dust was blasted into space, and then there was enough gravity to pull it all back down to the comet. So lots of dust, and it was attracted back by the minuscule gravity of Temple One. As you can see, the camera on Stardust Next isn't quite as sharp as the Deep Impact. Next one was NEAR. And to tell you the truth, I honestly forgot what that acronym was for, but it was actually designed to actually fly by two asteroids, Malahide and Eros. And as you can see, it's just basically a package with some solar panels on it. There's nothing on there which would indicate that it was going to land on anything. So after it was done with Malahide, it got caught up with Eros, and it took some really neat pictures of this potato-shaped asteroid. All sorts of wonderful pictures. And somebody at NASA said, you know, it's really too bad we can't land on that. Now, you never, ever tell an engineer that he can't do something. An engineer said, I'll bet you I could land on it. And they did. They actually modified the orbit so that it would get closer and closer. And then they slowly nudged it down so that it skidded to a halt. It actually stayed active for almost a year, sitting on that asteroid. So like I say, you never tell an engineer you can't do anything. So it took lots of pictures. It discovered iron and oxygen and silicon on that asteroid. And it also found, while it was in orbit, it found something else. And this is really a mystery. It's that thing right over there. And when you zoom in on it, it kind of looks like something that I think I'd rather not talk about. So you wonder, gee, is there a possibility to mine things on other asteroids? And the answer to that is yes. The next one out was Dawn. Dawn was actually a space probe that had a different kind of rocket engine on it. It had an ion engine, which is actually very, very low thrust, hardly uses any fuel at all, and will last for years and years and years. So the idea was they were going to launch Dawn in 2007. It was going to get a little bit of a boost from Mars, and then it was going to catch up with Vespa and then Ceres. And while they were doing it, was just going to orbit those asteroids for a while and then move on to the next one. And it did. It was just an amazing piece of equipment. It took several years for it to get out to Vesta, and it showed this rock orbiting in space, seems to have some racetracks down the equator of it. Took lots and lots of pictures of it, and then it went on to Ceres. This is the best picture of Ceres we have with the Hubble Space Telescope, and that was in 2003, 2004. And then we started getting better pictures. And if you remember, that was the one that had the two bright dots on it. Probably several more, but it had those two bright dots. The engine was extremely reliable. I mean, like I say, it lasted for years. It had more than 40,000 hours of thrust on it, which is quite considerable. So Ceres is the largest asteroid, and it stayed and still in orbit around this asteroid. And it took, like I say, thousands and thousands of pictures of it. It totally mapped the ice volcano that is on the planet, on the moon. I'm sorry, dwarf planet. And you can see it had enough orbits around it so that it has a total three-dimensional view of it. The surface came out with amazing detail. And even the white spots show that three-dimensionally, they are actually close to the surface. They aren't any kind of mountain at all on the surface of Ceres. But the question remained, what are they? And there were lots of answers. But the answer that I like the most is this one. I think it was target practice. Oh well. By the numbers, more than 69,000 images were taken, 48,000 hours of thrusting, 2,400, almost 2,500 orbits around Vesta and Ceres, and 2 new worlds explored. Just an amazing, and um, it's still orbiting Ceres. Now the next few missions were equally amazing. We have Itokawa, Itokawa, which is the asteroid. It's in Japanese, and the Japanese Space Agency decided that it was going to get samples of this particular asteroid. So what it was going to do was send a spacecraft out there. It was going to reach down, grab a handful of stuff, and then bring it back to Earth. And while it was there, it was going to drop a couple of cameras and probes on the surface of this on this asteroid, and it's going to take pictures and measure the temperature, all sorts of wonderful things. So here is the orbit of Itokawa, and as you can see, it was going to catch up with the asteroid. And there's the picture of the sample retriever. It was going to kind of come down, grab a handful, and then go back up again. With the amount of gravity that was on that asteroid, it was hardly anything at all. In fact, it was so little that when they released the little probes there on the right, by the way, they're called Minerva, who knows why, they actually released them while the probe was going up. So so Minerva actually picked up on the upward movement of that probe and actually went into orbit around that particular asteroid, which is really too bad. But they learned from that, and so it took a whole bunch of took a handful, and it sent it back to the Earth with a capsule that landed on the Earth. And when they took a look at it, they found that the spatula that picked up the material had not only artifacts on it, but it had olivine, which is actually an earth metal as well. So somehow they didn't quite isolate that that material well enough. And so as a result, uh, it may have been contaminated. The dust that it was collected, they figure was at least 8 million years old, but it may not have been protected well enough to prevent some type of contamination. So a second try was scheduled. Now, the most amazing flight that I have ever seen was this one, the Rosetta mission. This one, in my opinion, gets the first prize for the best use of gravity assist. It's just amazing. That outer ring is the orbit of Comet 67P. As you can see, it goes beyond the orbit of Neptune. So it was a repeating comet, but it is still a comet that started off in the Kuiper belt. The probe spent more than 12 years in space before it ever got to the comet. Launch was in 2004, and the idea was to orbit the sun until it met with the Earth again. It got a gravity assist from the Earth in 2005, sent out, and then it had a Mars gravity assist in 2007. And then it had, in 2007, a second gravity assist. And then there's the comet coming, going around. There's the tail, and now it's heading out into space again. There's the third gravity assist, and now that space probe is going to catch up with that comet. It's entering space, deep space hibernation, and for 3 years it was hibernating. And finally it comes out of hibernation in 2014. And here's the probe actually going around the comet. There's the comet. Doesn't look like much, does it? Kind of looks like a dumbbell, doesn't it? Now, the amazing thing, these are pictures of that comet. And meanwhile, as the orbit of the comet will take it closer to the sun, it actually begins to outgas. The materials that are in that comet are sublimating and actually pushing atmosphere into space. And some of this stuff is pretty considerable, could actually change the course of these comets. So they had to allow for that. Keep in mind that these are well beyond any kind of instant communication. So we're talking about artificial intelligence here to catch up and go into orbit around these comets. So the idea was it was going to drop its load, pre-separation, and Philae is actually the probe that was going to land on that comet. Now you'd think after 12 years, something had to break. And it did, but not much. When the probe landed on the surface of this comet, it was supposed to send spikes into the ground to hold it there so it wouldn't bounce. But it did bounce because that broke. It actually, the first time it hit, it actually bounced more than a kilometer back into space. 2 hours later, it finally came back down again and bounced again. Only this time it was a little bounce. It actually came back down after about 6 or 7 minutes. So now Philae was actually on the surface of Comet 67, and there was a problem. There's a picture of it in that little box, and that was taken by the orbiter that was going around that comet. And that orbiter saw that it seemed to be in an outcropping. In that probe, they found that there was no sunlight that was reaching the solar cells. As a result, it was losing power. It only lasted several hours. And then it went cold because it actually got smashed up against an outcropping that blocked the sun. So after several hours, the probe, the lander, was dead. So all that bouncing around, it took a look around itself, and that was the last pictures that it took. After this, the probe was dead. It's sad. I mean, God, it made it all the way out there in 13 years, but you can't. They did come up with one very important piece of information. They were able to analyze the surface of that comet, and they found that they have discovered something that possibly had a sale value. So if you want to smell like a comet, you can buy it. Meanwhile, the Japanese did have their second chance. This was Hayabusa 2, and it was going out to asteroid Yugu, and it was going to pick up a sample and then fly it back to Earth. So the idea was it was going to catch up with this asteroid, interesting looking asteroid. And then what's interesting here is the fact that as you get closer, you'll see the shadow of the probe. Isn't that neat? Almost looks like a Canadian flag. Anyway, but there's the shadow of the probe, and it was going to come down once again, grab a handful of stuff, and get it back to the Earth. So there's the probe coming down, grabs a handful of stuff. You can see all sorts of stuff trailing behind it. Now, what did it do when it was on the surface of that comet? It actually blew a whole bunch of gas into the surface and then grabbed some. So 14 times slower, you can see it just blasted a hole. And that's what comets are made up of. It's actually loose material, all held together by the minuscule gravity of that object. And then after it grabbed the material, it took back off. And it'll send back that probe, and that probe will actually come back to Earth. I believe it's the winter of 2020. So later on this year, we're going to see the results of that landing. While it was there, it made sure it was going to uh, drop some probes on the surface, and it would take pictures of the surface of that comet. I'm sorry, asteroid. Next one, this is the last one I'm going to talk about. And this one is actually the probe right now, OSIRIS-REx, that's the name of the satellite, is orbiting this asteroid. This asteroid is called Bennu. It's been orbiting this asteroid for about a year. And it too is going to drop to the surface of this asteroid, take a handful of stuff, and send it back to the Earth. So it's going to, once again, catch up with the asteroid Bennu. Right there. And it took some pictures of the surface of this particular asteroid. And you can see again, it's a very loosely packed surface. And they've already, I know that this probe, they've already rehearsed actually getting down to the surface. The only thing they didn't do was pick up a sample, but they have actually gotten down to the point where the probe actually touches the surface and then goes back up. But actually that probe will grab a handful of stuff somewhere around the middle to end of August, this August, and then it'll take that sample, put it back into a capsule for its return back to the Earth in the year 2023. So we're going to see, that come to an end very shortly. So the reason why they're so concerned about this particular asteroid is because in the year 2030, 2135, it it has a chance of colliding with the Earth. And they want to know how best to avoid that. It has about a 1 in 2,000 chance. So in the year 2135, we're looking forward to that. Meanwhile, as it does orbit, occasionally it'll send out a trail of material just because the sun's gravity will actually pull it away. So we've seen the last two asteroids being looked at. The last one is the asteroid Bennu, has a diameter of about 500 meters, about 300 feet. No, it's more than that. It's about a mile wide, about 1,500 feet. So that can cause a little bit of damage on the Earth if it hits it. So we're studying as much as we can about that. Okay, so we've actually landed on, if you not include the Earth, we've landed on 9 bodies in our solar system and visited 64 others. So we have a pretty good idea of what's going on in our solar system. Even though we don't understand everything, we have a fairly good idea of the materials that make up our solar system. Okay, don't forget the eclipse tomorrow night. Also, next week, July 10th, It's the last program of the series, the challenge of visiting other worlds beyond our solar system. Okay, so that's going to be an interesting one. And yes, we might talk about warp drive, but that's not a viable option at this point. Next series starts on September 11th at 8 o'clock. Potatoes on Mars, tube worms on Titan. Keep in touch with Drake.edu Observatory public nights, and you'll get the link if we need it for next fall. The observatory may be open, at which point I'll be doing it there. If not, I'll be doing it here. Okay. If you do have any questions, I'm certainly open to taking those, and we'll see what you're answering then.